Hello, everyone, and welcome to Virtual Planetarium, Exploring Space, part of our MOS at Home programming. My name is Janine, my pronouns are she and her, and I'll be your moderator today. That means I'll be reading some of your questions, which you can submit below using the Q&A button at the bottom of your screen here in the Zoom meeting. If you'd like to see captions during today's program, you can click the Closed Captions button at the bottom of your screen and select Show Subtitles. And if you're joining us on Facebook or YouTube, hello! We're so excited to have you here today, but unfortunately, I'm unable to see any of your comments on either of those platforms. We're so delighted to have all of you here today as our audience. Let's meet our flight crew for today's journey.
Hello, everybody. My name is Talia. I use she, her pronouns, and I am going to be the presenter today, which means I'm going to be doing most of the talking, but I do need a little help.
Hi, everyone. My name's Katie. My pronouns are she and her, and today I will be your pilot for this program.
And you have come to us in the second week of our Mars month. So February, we have declared to be Mars month. And today we are talking about some of the ways we explore Mars. And it's already been a big day for Mars today. I'll get into that a little bit later. But we'll start with a look at, Mars itself. This is our next door neighbor, the next planet out from the sun. It is the easiest planet in the solar system for us to get a spacecraft to. Every 2 years or so, a launch window opens up that would allow us to get a spacecraft to Mars within a reasonable amount of time. And it is a fascinating world. It's a world that today looks very different from Earth. It's very cold. It has a very thin atmosphere. It, of course, has this distinctive reddish color to it. It's a very, looks now like a very inhospitable place, but it's also a place that we think used to look very different. We think it used to be a lot more Earth-like. And so there's a lot of reasons why we like to send spacecraft to Mars, and we can't send humans yet. So we do just send robotic spacecraft. And over time, there have been a few different types of spacecraft that we have sent. And these can fall into one of 4 broad categories. So over time, we have sent flybys, orbiters, landers, and rovers. Now, the rovers tend to get a lot of the attention, and we'll talk about them. But first, let's talk about some of these other kinds of spacecrafts. So the very first spacecrafts that we ever sent to other planets, to Venus, to Mars, anywhere, they were all what we call a flyby. Now, a flyby, as you might guess from the title, is a spacecraft that just flies right by. It doesn't go into orbit, it doesn't stay, it just takes data as it flies past. And the reason that some of our first missions did this is because this is a relatively easy way to study another place in space, is by sending a spacecraft to just sort of fly past it. And so when we were just starting out, that's what we did. And the very first spacecraft that ever performed a Martian flyby was this one. Its name was Mariner 4, and it flew past Mars in July of 1967. July of 1967 was the first time we ever sent a spacecraft to Mars. And it, like I said, just went straight past. Now, of course, that's not your preferred way to study another planet, right? Because ideally, you'd like to stay and study it over time. And as successful as Mariner 4 was, it flew past Mars in July, and it lasted for several more months after that. So not bad for a first mission to another planet. But ideally, you really want to be able to stay there for a while. So we don't mostly do flybys anymore, as we have gotten better at this whole interplanetary missions thing, humans as a species. We don't do them very much, but it's not like we don't ever do them. I'd like to remind you, those of you who are around and maybe have heard of the New Horizons mission to Pluto. It was the first and so far only mission that has ever seen Pluto or the Kuiper Belt up close. And it was a flyby. It flew past Pluto in July of 2015. And the reason for that is because one of the great things that makes a flyby easy is that the spacecraft doesn't have to slow down to enter orbit. Slowing down takes a lot of fuel. And to get New Horizons to Pluto in only 9.5 years, that's it, 9.5 years to get to Pluto. That was really quick. The spacecraft had to get going very quickly, which means it really couldn't carry enough fuel to slow down. It didn't have the option of entering orbit around Pluto. It was always going to be a flyby. So that's one mission that famously recently used flybys. And another one was much less well known, and it was a flyby of Mars. Let me introduce you to these little guys, Marco A and Marco B. Marco standing for Mars Cube 1. These guys are tiny. They are what we call CubeSats, little tiny spacecraft that are very small, very light, and therefore pretty inexpensive to launch. And these guys actually hitchhiked to Mars. They were carried along with a lander that we're going to talk about a little bit later in 2018. And they performed the first Mars flyby that any spacecraft had performed in decades. So I can't say that we don't ever do flybys anymore, because clearly we do. However, given the choice, what we would like to do is stay there for a while. And with Mars, we have figured out how to do that pretty well at this point. I will say in the early years, we lost a lot of Martian spacecraft, even just trying to go into orbit. And a spacecraft that lives in orbit around the planet is called an orbiter. Go figure. And the very first orbiter that successfully entered Martian orbit also happened in the 70s, Mariner 9. So the Mariner, you might have noticed it has the same name as the first flyby. There was a series of 10 Mariner missions. Mariner 4 was the first Martian flyby, and Mariner 9, just a few years later, was the first spacecraft to go into orbit around Mars. And actually, it ended its mission in 1972, but it's still there. It ran out of fuel in 1972. It ended its mission, but it is still there. It's still in orbit around Mars. And we expect that actually next year, and it's expected sometime in 2022, Mariner 9 is finally going to fall out of orbit. Now, if that happened around Earth, it would just burn up, because Earth has a nice thick atmosphere that's hard for things to get through. Mars doesn't. It has a very, very thin atmosphere. So it's expected that when Mariner 9 falls out of orbit, it might not burn up. It might actually make it all the way down to the surface and leave a Mariner 9 memorial crater in the surface. So that was the very first of the Martian orbiters. I'm going to have, well, let's take a closer look at Katie's screen right now so that we can take a look at just how many we have today. So when you all, at least those of us here on the East Coast, when we woke up this morning, these are the number of Martian orbiters that we had. We have, I think it was 6, including the, let's see if I can name them all. Odyssey, Mars Reconnaissance Orbiter, Mars Express, Mars 1, Trace Gas Orbiter, and Maven. There we go, got them all. And they're in different types of orbit. And the reason we like putting spacecraft in orbit is because they get a global view. They get a look at the entire planet. And they can watch how different parts of the planet change at different times of the planet's year. These different orbits that they're in give them different perspectives. And they can watch seasonal changes happening over years. Some of them are specifically, like Maven or the Trace Gas Orbiter, are specifically looking at something like the changes in the atmosphere over time. Others, like the Mars Reconnaissance Orbiter, are looking for changes in the surface over time. So we get a long-term perspective when you use these orbiters. And when I say long-term, I mean, some of them are pretty long term. Katie is actually giving us a great view. Actually, we can see the 3 oldest spacecraft in Mars orbit, Odyssey, the Reconnaissance Orbiter, and Mars Express. And let's go ahead and zoom in on Odyssey, because this is the granddaddy of Martian spacecraft right now. This one is called Odyssey because it's named after the book in the movie 2001: A Space Odyssey. And it's named after it because it's been in Mars orbit since 2001. In April, this little bad boy is celebrating its 20th birthday in Martian orbit. And then right behind it are Mars Express, which is 18, and Mars Reconnaissance Orbiter, which is 16 this year. So we get our money's worth out of these orbiters these days. And they're also vital pieces of our missions to the surface. We actually have our surface missions send their communications back to Earth through our orbiters. So Odyssey, Mars Reconnaissance Orbiter, Mars Express, MAVEN, these are critical pieces in the surface missions as well. And about those surface missions. So far we have looked at things that study Mars from space. We've looked at in fact, let's take a pause for any questions, Janine, that may have popped up before I move on to surface missions. Have any questions about the flybys or the orbiters popped up?
We do have a question about flybys. The question is, how long do flybys on average take? How long do they gather data for?
Very good question. It's usually the data taking is relatively short. So it's usually the few days leading, or months sometimes in the case of New Horizons, the Pluto flyby. But in the case of a Mars orbiter or a Mars flyby, it's really the big data that you're going to get would be the days leading up to the flyby itself. And then for maybe an hour on either side of the flyby itself. And then sometimes they can look back and take more data as they're flying away. New Horizons was able to do that. Marco 1 or Marco A and Marco B, the Mars Cube 1 flybys, their big sort of test was more on the way to Mars. They were sort of testing, could a CubeSat, a tiny little inexpensive thing, produce usable data? The answer was yes, they were highly successful. So they were kind of a technology test. So flybys are really taking a snapshot of the place they fly by. They're not doing any sort of long-term study, which we like to do.
We have a question from Aubrey, who is 10. Is Mariner 9 on that chart that Katie was showing? And if so, where?
Unfortunately, this chart only shows current missions. And as of this morning, it is no longer accurate because there is another orbiter. A new orbiter entered Martian orbit this morning. HOPE, which is the first Mars mission from the United Arab Emirates, successfully entered orbit just after 11 o'clock a.m. Eastern time. So there are now 7 orbiters going around Mars. There were 6 when I woke up this morning, and now there are 7. So I was very excited to see that happen. So I did promise you surface missions. So let's go move on from the orbiters. And now there are 2 types of surface missions. You have landers and you have rovers. I've noticed it seems to be a trend to call anything that is operating on the surface a rover, but a rover is specifically something that you put on the surface that moves around. And a lot of the things we've put on the surface don't move. They stay in one spot, and we just call it a lander. So the very first lander was Viking 1. This is a model of it. And it landed in July of 1976 and was very, very closely followed by its twin sibling, Viking 2, which I think landed in September of 1976. So these were the first surface missions. I should say the first successful surface missions. They were actually not the first to make a soft landing on Mars. The first spacecraft that made a soft landing on Mars was a Soviet spacecraft called Mars 3, but it's did not successfully carry out its mission. It did make it to the surface, and then it ceased to function. And this is a trend you see a lot in Martian spacecraft. Landing on Mars is very hard. It's different from landing on the moon or landing on Earth because Earth has this nice thick atmosphere that can help slow you down. The moon doesn't have any atmosphere that you really have to deal with. Mars does, but it's not enough of an atmosphere to actually be helpful. It's just enough that you have to deal with it. And everything has to be totally automated because the Mars is far enough away that any command sent from Earth takes several minutes to reach Mars. But it only takes about 7 minutes to get from orbit to the surface. So the spacecraft has to be able to do it all on its own without any help from Earth. And a lot of times that goes wrong. So there have been a lot of failed Martian landings, or things like Mars 3, which land and then cease to function once they've landed. So there's actually only been, a fairly limited number of successful surface missions. Viking 1 and Viking 2 were the first landers. They have, and they gave us our first look at the Martian surface. This is an actual photo from the surface of Mars. First time we ever saw that was thanks to Viking 1 and Viking 2. They have since been joined over the years by Pathfinder. If any of you watched The Martian, which I loved, it was very near and dear to my heart. Pathfinder is the old lander that the character recovers to try and communicate with Earth. The Phoenix lander, and still operating on the surface today, InSight. It was InSight that Marco A and Marco B hitched a ride to Mars on. So this one is currently operating on the surface, the only lander currently operating on the surface. So that's the landers. I will say, a lot of the attention tends to go to the rovers, and there's no wonder the rovers are really cute. They're just some of the cutest spacecraft. And in fact, the very first rover was also a hitchhiker. It rode down to the surface with Pathfinder. And it was this little guy over here. This is Sojourner, the very first Mars rover. It's this tiny little thing. It rode down with Pathfinder to the surface in July of 1997. That mission lasted a couple of months on the surface. And then there were the twins. You'll notice there's been 4 successful rovers on the surface so far. You'll notice there's only 3 pictures. That's because this middle picture here is what both Spirit and Opportunity looked like. They were twins. Spirit lasted for 7 years on Mars. 7 years. And that is nothing compared to its twin, Opportunity. Opportunity lasted for 15 years. Not bad considering both of these spacecraft were supposed to last for 3 months. 3 months. And Spirit is actually an example of a rover that became a lander, basically. Spirit ultimately got stuck in the dirt many, many, many years after its mission was supposed to have ended. It was still roving around. It got stuck and basically became a lander for the last couple of years of its life. Opportunity succumbed ultimately to a dust storm. These 2 rovers were solar powered. The dust storm prevented the rover from getting any power, and it ultimately froze, which is too bad. I would have loved to see how long this little rover could go. And I will say that even, Opportunity, which is the longest lived rover we've ever had, only covered about 28 miles over the course of its life. So even a very long-lived robotic spacecraft can only cover a very limited amount of space, which is why we really want to send humans. Humans can do this a lot faster. Currently operating on the surface of Mars is the largest rover that we currently have on the surface. That is Curiosity. That is an actual photo of it because it can take selfies. And that's what it looks like. And it is still operating on the surface today. And just to give you an idea of how much the size has changed over time, these are scale models of each of these rovers. So there's little Sojourner, that first little rover. And here's what Spirit and Opportunity looked like. They were often compared in size to, say, like a golf cart. And this big, huge thing over here is Curiosity, usually compared in size to like a Jeep. So those are the sorts of spacecraft that we have sent to Mars. And that is what the sorts of things we have there. Even right now, let's go ahead and highlight Katie's feed again so that we can get another beautiful view of the red planet. And what we have on the way, of course, Hope just arrived in orbit today. So there's, like I said, a new Martian orbiter. Tomorrow, there's going to be another new Martian orbiter as the first Chinese Mars mission enters orbit, probably sometime tomorrow morning. We're not completely sure. That one is kind of ambitious. It's an orbiter lander rover combo mission. It's going to enter orbit tomorrow. It's going to send a lander to the surface in May. And that lander, like Pathfinder before it, is going to deploy a small rover. But of course, all eyes are on the mission that still has another week or so to go. And that is the next big Mars rover, Perseverance. Perseverance is going to arrive next Thursday. So it's going to arrive on the 18th. It's getting very close. It's another huge huge rover, like Curiosity. And Katie's looking for it right now. It's somewhere nearby. There it is. Also called the Mars 2020 rover. And this thing is another Jeep-sized rover. It's going to be another big operator on the surface like Curiosity. This one has all sorts of cool stuff on it. It's going to try testing out making our own oxygen on Mars. It's going to deploy a little helicopter to fly around on Mars. It's going to gather up samples of Martian dirt that we can then pick up someday and bring home to Earth. This one I'm very, very excited about, and that's landing next Thursday. Tune in to this program next week. We're going to be talking all about Perseverance. But right now I have talked a lot. Janine, have there been any questions that have popped up that I should answer?
I like this one from Maureen, who asked, how do dust storms on Mars affect the landing of rovers and landers?
This is an excellent question. So fortunately, we've never had to land during a dust storm before. There was a little bit of concern because the dust storm that ultimately took out Opportunity took a long time to die down, and we weren't sure if it was going to die down before InSight had to make its landing. It ultimately did. So InSight did not have to land during the dust storm, but these do pop up from time to time. And in theory, the spacecraft should be able to land on their own in spite of it. But like I said, landing on Mars is really, really hard. And I know if I was a NASA engineer and there was a dust storm during the landing sequence of my spacecraft, I would be very, very anxious.
We have a question about how long it takes to get to Mars for these missions.
It takes between 6 and 10 months. So all three of these spacecraft launched in July at different points in the month of July, and they are now just arriving in February. And that's pretty standard, usually around 6 months. It can take 10-ish, depending on how much fuel you're willing to use at the outset. And that is, using that launch window that pops up every 2 years. Technically, you could launch to Mars anytime, but if you do it outside of that launch window, it's going to take you a whole lot longer to get there. And so you're better off just waiting for that launch window that'll let you get there in 6 months.
All right. Yeah, it's always good to take the well-timed, easy route. We do have a question just in terms of features of Mars. What is the gray circle on the top of Mars? Maybe we want to spotlight Katie's video again.
That is one of the things that's very interesting about Mars. That's its polar ice cap. So this is the northern polar ice cap. There is also a southern polar ice cap. It's not quite as big. And these are a mix of water ice and carbon dioxide ice, which we call dry ice. because Mars's thin atmosphere is mostly made out of carbon dioxide, and it's so cold at the poles that the atmosphere can actually freeze out and form part of that ice cap. So that is what you're looking at. You're looking at the Mars ice cap.
And then maybe we can talk a little bit about like when dust storms happen on Mars and how long they last.
Yes. So the little ones happen all the time. Brief ones that happen over the course of like days. But we've seen a couple of these big global dust storms that whip up dirt all over Mars. And it has to do with the fact that Martian dirt in a lot of places is very, very, very fine and therefore very, very light, very easy to lift up into the air because there's not a lot of wind pressure on Mars. It doesn't have, like I said, not much atmosphere. So those happen maybe like once or twice a decade. And when they do, they can consume the entire planet. The entire planet can be covered by this dust storm, and they can last for months, many, many, many months. And that's what killed Opportunity. A solar-powered rover doesn't have much of a chance if it can't see the sun. And that is what happened. And it didn't affect Curiosity because Curiosity is nuclear powered. It doesn't depend on the sun. And that's Perseverance as well. Perseverance will not depend on the sun. And we were willing to take that risk for Spirit and Opportunity because they were really only supposed to last 6 months or 3 months. So we were pretty sure that during that 3-month period, the odds were there wouldn't be a big dust storm. Of course, Opportunity went on to live for another 15 years. So the dust storm got it eventually. It did survive another dust storm, another big one that wasn't quite as thick, quite as dense. It was still able to get some sunlight. But this last one that happened in 2017 just was too thick. It was a sad day for me.
Yeah, we miss Oppie. Such a good little rover. I think that's all the questions we have time for. So thank you all for joining us. I'll let Talia and Katie say goodbye however they'd like to.
Bye, everybody.
And I would like to thank all of you for joining us today. We are sorry if we couldn't get to your question. There were lots and lots of them. We will, as Talia said, have another Mars-themed, Perseverance-themed episode show again this time next week. So tune in for that again. If you'd like to see what other virtual programs we're offering, you can follow the museum on our social media channels or check out www.nos.org/nos@home. If you enjoyed today's presentation and would like to support more programming like this, please visit engage.mos.org/welcome to support MOS at Home. And thank you to everyone who already has. Today's program was produced using the free software NASA's EYES, which you can find at eyes.nasa.gov. Thank you all again for all of your questions and answers, and we hope you'll join us again soon. Bye.